Kellyanne, we have to build a great big box along the southern border, and we have to make Mexico pay for it.
Great idea, Mr. President, but how much is this wall gonna cost?
Let's find out so we can give Enrique Peña Nieto an estimate. But make sure we don't include alternative facts.
Okay, our packing company needs to construct a rectangular storage bin with an open top and a square base, and is to have a volume of 300 cubic meters. Material for the base costs $12 per square meter, while material for the sides costs $7 per square.
Alright, this is great. Really great. Absolutely tremendous. Let's make a function to model the cost in terms of the length of the base.
Great. Really great.
And let's call the base B, as in B for base.
You sure do know your alphabet, Mr. President.
I know. It's great. I know.
Okay, we should start by drawing our storage unit. After that, we should include the volume formula, and because the base is square, we can use b squared, and multiply b squared by the height, setting that equal to the original volume of the 300 meters cubed. Next, we need to make a cost function, which would be $12 times the base plus $7 sides. After doing this, we'll need to combine the function. Because the base is $12 per square meter, we can do b squared times plus the cost of $12. Because there are 4 additional sides, we can use the cost of the sides, $7 times 4 times the base of the height. Because we don't want 2 variables in our equation, we can solve for the height in our volume formula, and then substitute in this formula for our height value. This gives you the formula of 12b squared plus 28b times 300 over b squared. Our final step is to simplify this equation by multiplying 28 by 300, then dividing out the b, resulting in 12b squared plus 8400 over b.
Wow, what a great function. I think it's going to be a home run with the American people. I mean, the reaction's going to be huge. We're going to have the greatest functions anyone's ever seen. But how do we use it?
Well, I'm not sure. Let's talk to Steve Bannon. He always knows what we should do.
Greetings, Mr. President, Miss Campaign Advisor. What can I do for you today?
We need to figure out how to use this function for the minimum cost of the bid.
Okay, so get your graphing calculator ready, Kellyanne.
Yes, sir, I'm ready.
First you need to set your window. Pick an X value in which the base of the box would be reasonable for the box to be less than 25 meters. Set this as your X minimum. This is based on the volume of 300 meters cubed. There can be no negative length, so the X minimum must be greater than 0. You know, you want to find the minimum cost of the bin. You turn your Y value. This the cost needs to be positive, so a good start would be 0. And if you want the box to cost $4,000, choose a number significantly larger so you can see the whole curve. 7,000 is a very reasonable in this case.
Okay, that's very good.
Now that your window is set, you need to go trace, min, and move the cursor on your right curve and left curve about the minimum. When this is done, you should see a coordinate that gives a minimum cost on point 7.05 and 1787.92. I think the length of this box should be greater than 10 meters, but let's keep Mexico as an ally and make the cost relatively cheap, say $4,000.
How strategic, Mr. President.
You'll need to set y equal to $4,000 in your calculator. Next you'll need to graph these points and find the intersection with your x value greater than 10.
I got it. The point intercepts at 17.1 and 4,000.
And this means that the width of the box is also 17.1 meters because it's squared. How bigly great!